Oh, sorry, just fixing my window. Okay, what are we doing? Okay, Chapter 1, Lesson 2, Pre-Calculus. Don't send it. Chapter 1, Lesson 2, Pre-Calculus, looking at the characteristics of functions. Going to look at the last characteristic here that we're going to look at when we're analyzing functions, and that's called the end behavior. And the end behavior is looking at how the functions behave as it goes towards either end. In other words, as it goes out towards positive infinity, what's happening out there. As it goes down towards negative infinity, what's happening out there. This is the end behavior. Now, the horizontal asymptotes give us one kind of end behavior. It tells us that out there at the ends, the graph is approaching this horizontal line. And again, as we talked about in asymptotes, that horizontal asymptote, really a better name might be the end behavior asymptote, because it does kind of control or give us the boundaries of the graph as it approaches either end. Now, not all functions are going to approach a line way out there. All the functions don't have horizontal asymptotes. There's some functions that don't have any kind of end behavior, let's say, or towards an asymptote. They do have end behavior, but at the asymptote, it's what happens. So we just want to be aware that not every function that has an end behavior needs to have an asymptote to have that end behavior. Okay. Now, if the end behavior, if out there at the ends it does approach a line, we were going to use limit notation to describe what's happening out there. And we talked about limit notation in another video. We're going to use it in this video and show you how it needs to be done. Now, for now, we're going to just use our calculators to look at end behavior. Later on in the year, as we get better and more adept at looking at equations and getting a picture of the function in our mind, we'll be able to tell it without actually using our calculator. But for right now, we'll use our calculator. So I think the best way to do this is, I think I'm going to just give a couple of examples. And I've got these graphs worked out here, so we're going to go ahead and look at this one here. So here I have the graph of x squared, get out of there, x squared plus 2 over 2x plus 1. And you'll notice if we look at it algebraically from our last example, we know the degrees are equal here, numerator degree and denominator degree. So our end behavior asymptote is this leading coefficient over the leading coefficient of the denominator. So that's going to be 1/2. So we know there's an asymptote right here at 1/2. Now, and you'll notice that the graph out here at this end is getting close to that graph. So it's getting closer and closer to 1/2. And we notice as we go out here to the negative end, it also gets closer and closer to 1/2. So we want to describe the end behavior, and we're going to use limit notation to describe it. And here's how you're going to use limit notation. All right? Now, there's two parts to this. First of all is how do you write it? So first of all, we're going to say that the limit, so we use the abbreviation, as the x values go towards positive infinity. Okay, so this is how it needs to be written. The word limit, and then underneath the word limit, x approaches positive infinity. This is what is happening with the x values. The x values are going towards positive infinity. So the limit, what's happening out here as the x's gets larger and larger, is now over here you're going to give me what the y values are doing. In other words, these y values, as the line comes down, are getting closer and closer and closer to this asymptote, which is 1/2. So the limit as x approaches positive infinity, as the x values are getting larger and larger, the y values are getting closer and closer to 1/2, or they're getting closer and closer to that asymptote that we figured out earlier. So that's the right side of the graph. We also have to do the left side of the graph. So here we do the limit. Now here the x values are getting closer to or going towards negative infinity. What is the graph doing as I'm going here? So if I follow the y values over here are also getting closer and closer to the horizontal asymptote or the end behavior asymptote of 1/2. So the left side tells me what the x values are doing. They're going towards negative infinity. The right side tells me what the y values are doing. They're getting closer and closer to 1/2. Over here, the x values are doing what? They're going towards positive infinity. The y values are doing what? They're getting closer and closer to 1/2. So this would be the end behavior, a description of the end behavior using limit notation. Okay, let's do another one. So the next graph here I have, oops, that's not going to let me do it that way, I don't think. Oh, here we go. So here we have the graph. And again, the graph you can see is close to 0. It goes up, and then it comes back down and gets close to 0. All right? And again, we can look at this. The degree of the numerator here is 1. The degree of the denominator here is 2. The numerator is less than the denominator, so the end behavior, or horizontal asymptote, is at y equals 0. Now, we want to describe that end behavior using limit notation. So there's two sides to this. Here, the limit, as the x values are getting closer to positive infinity, is the x values are going out to infinity. What are the y values doing? They're getting closer and closer to my horizontal asymptote, which is at 0. Then over here on the left, what's happening on this side? Well, the x values are going to negative infinity. What are the y values doing? Well, they're getting closer to 0 again, that end behavior asymptote. So this would be a description of the ends of the graph using limit notation. Okay, do another one. All right. Now we're just looking at the ends of the graph, and again, you can kind of look at this. This degree is a 1, this degree is a 2. Numerator is less than the denominator, so my horizontal or end behavior asymptote is at y equals 0. So I want to describe the ends here now using limit notation. So over here on this side, the limit, as the x values are doing what? They're going to positive infinity. What are the y values doing? They're getting closer and closer to 0. Over here, the limit, as the x values go towards negative infinity, what are these y values doing? Well, they're coming up, but they're also getting closer and closer to 0. So you can see how the horizontal asymptote actually controls or tells me what the values are doing out either at the ends. Now notice this is a horizontal asymptote, but look, the graph does cross y equals 0 right here. So it's like we talked about before. Vertical asymptotes, the line cannot cross, the graph cannot cross. The horizontal can, because the horizontal pretty much controls or tells me what's going on out at the end, and I really use that for end behavior. Okay? So one more example, and it's kind of just to throw a trick at you here. What about this one? Now, we use limit notation when the graph is approaching an asymptote out at the end. This one does not approach a single line. This one is going towards positive infinity. This one's going towards negative infinity. Now, we can still use limit notation to describe that. We could say the limit, as the x values go towards positive infinity, so as I go out here towards positive infinity, what are the y values doing? They're going up to positive infinity. So the y values are getting infinitely large as the x values are getting infinitely large. Now what happens on this side? The limit as the x values go towards negative infinity is, what are the y values doing as you go this way? Well, the y values are going towards negative infinity. So we can use limit notation to describe these functions even though they don't approach a graph, don't approach a line. We can still use limit notation to describe what the y values are doing when the x values are getting very large out here, or what the y values are doing when the x values are getting very small or going towards negative infinity. So just remember that. This is what the x's are doing. This is what the y's are doing. Okay? And that's limit notation, and that's end behavior.